Imagine a needle, yes, a mere sewing needle traveling at the speed of light, and it hits our planet Earth. What do you think will happen? Today, we're taking a trip into the realm of the hypothetical to explore the question of what would occur if a needle made contact with Earth at light speed. Our challenge? Grasping the potential impact of this event. Our solution? Diving into the captivating world of science to simplify and explain this complex scenario. In this video, we uncover the fascinating and somewhat terrifying consequences of this unlikely event. To comprehend what would happen first, we need to grasp the concept of light speed. Light speed, my dear friends, is not just a number. It's a fundamental constant of nature, a cornerstone of our understanding of the universe. It's approximately 186,000 miles per second, a speed so fast that it's nearly incomprehensible to the human mind. But why is light speed so significant in physics? Well, it sets an absolute speed limit in the universe. Nothing, absolutely nothing, can travel faster than light. It's also directly related to energy. You've probably heard of Albert Einstein's famous equation E equals mach squared. This equation tells us that energy, denoted by E, is equal to mass, denoted by m, times the speed of light squared, denoted by c squared. So, the faster an object moves, the more energy it carries. Now let's talk about our needle. It's tiny, right? It's so small that you might think it's insignificant. But let's imagine this needle is moving at the speed of light. According to Einstein's equation, even something as small as a needle could carry a massive amount of energy if it's moving at such a high speed. This is because the speed of light squared is a very, very large number. So even if the mass of the needle is small, when you multiply it by the speed of light squared, you get a very large amount of energy. This energy is so enormous that it's equivalent to the energy released by many nuclear bombs. So we've established that our needle, traveling at light speed, carries an extraordinary amount of energy. But how does that affect the Earth? Well, that's a story for another scene. Stay tuned. Our needle, now a small but mighty cosmic missile, hits the Earth. Imagine a speck of dust, but with the power of a nuclear bomb traveling at the speed of light. The impact it would cause is nothing short of cataclysmic. Let's draw a comparison to known meteor impacts. The meteor that wiped out the dinosaurs, for instance, was about 6 miles in diameter and resulted in an explosion billion times more powerful than an atomic bomb. Now, our needle is much smaller, but traveling at light speed, it carries an unimaginable amount of kinetic energy. The moment this needle touches the Earth, it would vaporize instantly, unleashing a shockwave of energy. This energy, in turn, would create a massive explosion. The force of this explosion would be so powerful that it would create a crater hundreds of kilometers wide. The surrounding area would be flattened, and a cloud of dust and debris would be sent high into the atmosphere, blocking out the sun and causing a nuclear winter. But here's where things get even more intense. The energy release would be so immense that it could potentially split the Earth in half. Yes, you heard that right. A needle, something so small and insignificant, could, under the right circumstances, have the power to cleave our planet in two. This might sound like a scene straight out of a science fiction movie, but it's all based on the principles of physics. Energy is neither created nor destroyed, it simply changes forms. And in this case, the kinetic energy of the needle is transformed into a destructive force that could potentially split the Earth. But let's not get ahead of ourselves. While this scenario is theoretically possible, it's highly unlikely. The chances of a needle traveling at the speed of light and hitting the Earth are astronomically low. But it's fascinating to imagine, isn't it? So the Earth is now in two pieces, but what happens next? The aftermath of this event is as intriguing as the impact itself. It's a spectacle that defies imagination. Let's try to picture it. As the needle slices through the Earth at the speed of light, it leaves a trail of cataclysmic destruction in its wake. The Earth, as we know it, would be cleaved in two. Now, one might wonder, what happens to the two halves of the Earth? The answer lies in the invisible forces that govern our universe. The gravitational pull of each half would cause them to be drawn back towards each other, attempting to reform the planet. However, the immense energy released by the impact would likely cause the two halves to melt and vaporize, transforming our beloved blue planet into a fiery ball of molten rock. The impact would also have significant effects on the Earth's orbit around the Sun. The sudden removal of mass from the Earth would cause it to drift away from its original orbit, potentially leading to a new and unpredictable path around the Sun. This could result in drastic changes in climate and seasons, making the Earth uninhabitable for most forms of life as we know it. Speaking of life, the aftermath on the biosphere would be catastrophic. The vast majority of life, from the smallest microorganisms to the largest mammals, would be wiped out almost instantly. The surviving organisms, if any, would have to adapt to a radically different environment, perhaps leading to the evolution of new life forms. Yet, in the grand scheme of the cosmos, this event would be just another day in the life of the universe. Stars explode, galaxies collide, and black holes devour everything in their path. The universe is a dynamic and ever-changing place, and our Earth is just a tiny speck in this cosmic dance. In the end, our needle's journey leaves a lasting mark on our planet and our understanding of physics. It serves as a stark reminder of the power of the forces that shape our universe and the delicate balance that allows life to exist on our little blue dot. But should we be worried about rogue, light-speed needles in space? Well, the short answer is, not really. Here's why. The universe operates under a set of laws, and one of those is the laws of physics. These laws dictate that it's incredibly unlikely for any object to reach the speed of light. You see, as objects gain speed, they also gain mass due to a phenomenon known as relativistic mass increase. This means that as an object approaches the speed of light, its mass becomes almost infinite, requiring an infinite amount of energy to keep accelerating it. Considering our current understanding of physics and the energy sources available in the universe, propelling a needle, or anything for that matter, to light speed is, well, virtually impossible. But let's not forget, our whole scenario was purely hypothetical. It was a fun and intriguing thought experiment, a chance for us to understand the immense power of light speed and the catastrophic consequences it could bring. It's always exciting to ponder these what-if scenarios. They push the boundaries of our understanding and fuel our curiosity. But remember, they are just that, scenarios, not realities. So, while a needle at light speed could cause some serious damage, for now we can continue our sewing projects without fear. Because the chances of your needle turning into a planet-splitting missile are, thankfully, astronomically small. So there we have it, the earth-shattering power of a needle at light speed. Isn't it fascinating to think about the tremendous impact such a tiny object can have? Today we've taken a journey through a hypothetical scenario, letting our imaginations run wild with the possibilities. We started by introducing the concept of a needle traveling at the speed of light, and what that could mean for our planet. We then dived into the potential impact, exploring the almost unimaginable energy it would release upon striking the Earth. We imagined our planet being split in half, a rather dramatic and catastrophic outcome, to say the least. In the aftermath, we contemplated the effects on the Earth's ecosystems, weather patterns, and even the planet's very orbit. It's a sobering thought how a single, seemingly insignificant needle can bring about such devastation. But of course, we ended on a reassuring note. We discussed the unlikeliness of such an event ever happening, the complexities of achieving light speed, the astronomical odds of a needle hitting the Earth at that speed, and the protective shield of our atmosphere all stand in the way of this potential disaster. Why go through all this, you might ask? Well, it's not just about the shock value or the thrill of imagining such a scenario. It's about understanding the complexities of our universe. It's about appreciating the delicate balance that allows life to exist on our beautiful planet. And most importantly, it's about fostering a sense of curiosity and wonder about the world we live in. So the next time you see a needle, remember the potential power it could wield in the right, or rather, wrong, circumstances. It's a reminder of the incredible forces at play in our universe, and how something as small as a needle can represent such profound concepts. In the grand scheme of the cosmos, even something as tiny as a needle can have a massive impact. Remember to stay curious and keep exploring the wonders of our universe.